So this is the second Infinitec blockchain applications workshop. I am John Soldatos from Infinitec project and the Hellenic blockchain hub. Today, the purpose, the objective is to present the latest developments of the Infinitec projects in blockchain technology, emphasizing in the use of blockchain technology for non-cryptocurrencies applications. So without any further ado, I'm going to do a short introduction to the workshop and to what we are discussing today. And then I will give the floor to our speakers to present themselves and of course give their talks and their demonstrations. Of course, throughout the workshop, we would greatly appreciate your comments, your feedback in the chat, but also your engagement with Infinitec project. I'm going to give some information in a while. So these last 2 years, they have been very active for the blockchain and for the crypto community. So 1 year ago, we've seen the crypto market booming, exceeding 1 trillion in market capitalization. Also, different things being on the news, and also a lot of companies and a lot of blockchain projects being implemented. Also, we have seen a high rise of a special type of blockchain market, the non-fungible tokens, NFTs for short. And I want to stick a few seconds to this growth. So, this is used to represent unique assets that gain value in a certain context, digital assets primarily, but also it's possible for physical assets. Now, the reason I'm mentioning this is on the one hand, because of the great market interest that you see here, which is ongoing. On the other hand, because Infinitec project has been doing, as you will see, work on tokens and on implementing token standards over the Hyperledger blockchain. So I think it's one of the themes that we will discuss later. Now, what we are doing in Infinitec, which is, as I would say, shortly a project that aims to provide showcases and demonstrations from the entire spectrum of digital finance. So a lot of use cases, including blockchain and non-blockchain use cases. So the use of blockchain in Infinitec goes beyond crypto, is actually for non-cryptocurrencies applications. And I usually use this slide to remind when it is a good idea to use blockchain in an application, in an industrial application, in this case, in a finance application. So whenever you want to have a decentralized control, so you want to have a decentralized application, because you cannot dispose with a central control, either because this is not a good idea, or because you can't trust any central third party to control your application. And of course, when you need to have, you need a database, and you need to have reads and writes in this database, and the writers do not necessarily trust each other. So when all these conditions hold, it is a good idea to consider a blockchain for your application. So this is our main motivation for doing several things with blockchain in Infinitec, like considering the know your customer process in finance, or as we will see later, a new demonstration that we have available on how you can implement a personal data market where every participant, every citizen, if you want, maintains control over their personal data at all times. And this breaks the traditional centralized data sovereignty model that we have currently on the internet. Now, on this concept, using this concept, you can use blockchain for a great number of applications in digital finance. I'm not going to go in detail, but I'm going to very quickly list these applications. So, like you can have, payments and payments clearance on the blockchain, payments and settlements of transactions on the blockchain. You can have automated trading transactions with smart contracts. Last year we had maybe those of you that might trade, we had the Robinhood case, which demonstrated, also the deficiencies of a centralized system from a regulatory perspective. So there is also some rationale behind automated trading. Of course, initial coin offerings and crowdfunding without a third party. This is also possible through blockchain. KYC, KYB, know your customer, know your business, and related anti-money laundering processes. Again, blockchain can accelerate this process and can make it probably more efficient because you don't necessarily have to provision the same data again and again. We will see an example later. Auditing, of course, because it's a technology that gives you transparency. So if you want to gain transparency on the transactions and so on, like in an auditing setting, in an auditing application, then blockchain might be a good idea. Also, if you want different parties that do not necessarily trust each other to share data for credit risk scoring or what is trending nowadays, embedded finance, you can also use a blockchain. Or if you want to do some risk assessment or security process on a collaborative fashion, again, blockchain might be a good idea. So in this context, that's today's agenda. We meet some of you 1 year later, 1 year before, during March 2021, we had the first workshop. It was also sponsored and supported by the Hellenic Blockchain Hub. And there we present the first round of applications and demonstration and developments of Infinitech. So we are coming back with a wave of updated applications and also new content, new ideas, new demonstrators on tokens, on personal data markets, and so on. So this is our agenda. And I'm not going to say anything about my colleagues, the participants from Infinitech project. I would rather ask them to take a minute to properly introduce themselves and their company, and then go on with their presentation when the time comes. Just to say that blockchain is a small part of what we are doing in a much wider project, which is the Infinitech project. It's a flagship 20 million euro project, 20 million euro budget project with 46 participants, including industrial partners, banks, insurance companies, academia, but a lot of fintechs also. And yeah, we are trying to show how things in the digital finance sector can be done better using data, and notably big data, but also deep tech technology like artificial intelligence, blockchain, Internet of Things, and so on. Now, it is very important for us to follow for you to follow our developments, but also for us to give you, valuable content, and we give different content in terms of solutions that you can download and you can use for free for your project or for your academic or research assignment. You can subscribe to. We give trainings and how-to videos. So to access all this, I kindly ask you to subscribe to our YouTube channel. We have already 63 videos there, and more are coming every day to register to the Infinitec marketplace. Again, there you will find over 25 solutions for big data and digital finance, like notebooks or blockchain demonstrators and so on. So again, please register to the Infinitec marketplace, subscribe to our newsletter, and most importantly, during today's workshop, but also after it, feel free to give us feedback, right? Give us feedback in the chat, ask questions to the speakers, and so on. So yeah, my time is up. So thank you anyway for being here. So I'm gonna stop sharing my screen, and I will ask my collaborator, Dimitris Miltiadou from Ubitech, to take the floor, take some time to properly introduce himself, and then describe and demonstrate his blockchain project. Dimitris, the floor is yours.
Yes, thank you, John. Let me take the floor and share also my screen. Okay. Hello, everyone. I'm Dimitris Miltiadou. I'm a member of Data Science and Analytics unit of Ubitech. We are a software innovative house engaged in and involved in many R&D and commercial activities. Today, I will be presenting our approach for a decentralized management of consent in finance applications. First of all, why do the financial institution needs the customer's consent? We all know the introduction of the PSD2 directive that is leading the way towards what we call open banking. Okay, so it notes that open banking will expand traditional banking data flows, actually by placing the customer at its core and in control of their banking data, including any personal information involved by the banks. Open banking also, as referenced by KPMG, it refers to the ability of the customers of a bank to authorize any third party to access their account data in order to either collect account information and perform some processes or to initiate payments. Additionally, Ernst & Young reference as on their report that PSD2 directive should be properly implemented in harmony with GDPR and other directives set by the European Commission in order for the banks to better protect and serve the consumers towards compliance and, of course, to seize new opportunities for growth. Now, why consent management is required then? Whenever we are sharing personal and sensitive information of customers, data privacy requirements arise. In the banking sector, the financial institutions are obliged to adhere to both directives, so both PSD2 and GDPR, and they need to find the proper balance between the data sharing introduced by PSD2 and, of course, the respective data protection introduced by GDPR. So the proper balance between these two directives is achieved by the consent of the customer of the bank to share their personal and sensitive information to third-party providers. So as you can understand, the need arises for a robust and efficient consent management by the banks. So what is actually consent management? Consent management is the process of managing the consents from the customers for processing their personal data. It involves the tracking, monitoring, and management of the personal data lifecycle from the moment of opt-in to data arrays in a GDPR-compliant manner. So it provides the customers the complete control over their data, enabling them to provide and at any time withdraw their consent, which allows them the authorized party to access this information and has immediate effect. So in order to consent management to be effective, it should enable granular permission consent that is considered the key enabler of trust for enabling and maximizing data sharing between the customers that should be comfortable to share their data. There are different approaches and solutions in the research and, of course, in the industry where the consent is handled differently in many different ways depending on the needs of a specific domain usually. And let me mention that the most widely explored right now domains are the IoT and health domains. So an approach actually facilitates the consent management functionalities via a web standard protocol, trying to be domain agnostic. However, these approaches are lack in terms of data access auditing, usually access revocation, and the right to be forgotten, which constitutes one of the main, let's say, aspects of GDPR. There are other approaches facilitating data ownership and data control, retention, mainly in the health domain. However, they are not based on mature enough technologies and further research is required. On another approach, the collection of informed consent is facilitated via mobile. But again, in this solution, it's obvious that it's focused on the mobile and there is usually a lack of support for web applications. Another approach is for the consent management lifecycle of personal data is mostly focused on data originating from IoT devices. So it's a domain specific that cannot be easily adapted to other domains. What is our solution? A blockchain-enabled consent management system that, since traditional technologies fail to become a key enabler of trust, as we all know, we have read and seen on the news and articles for multiple security data tampering incidents. So our solution is proposing a decentralized and robust blockchain consent management mechanism that enables the sharing of customers' consents to exchange and utilize the data across different financial institutions. So our solution enables the financial institution to effectively manage and share the consents of their customers in a transparent manner. So it provides the ability to store the consent and manage the complete update history of consent through consent versioning in a secure and trusted manner. Going through quickly on the supported use cases, you can see here a first diagram of how we are handling the creation of a consent. So a third-party provider actually initiates a request to the consent management system to get the consent of a customer of a bank. At the second step, the bank itself pre-approves after reviewing this initial request and forwards this request to the customer, where the customer can review, manage, and possibly edit and update the terms of the consent before it's digital signed and sent back to third-party provider to also digital sign and finalize this consent. The final step, of course, and the security is the insertion of all this consent info into the blockchain in order to ensure compliance on both PSD2 and GDPR, facilitate complete consent management lifecycle, and increase trust. Going a step further, of course, at any point, any of the involved parties can update the consent. So in this case here, we see that the customer can initiate an update with the updated terms that are digital signed again, and they are passed as a second step to the third-party provider in order also to be reviewed, approved, and digitally signed. At the last step, of course, these new updated terms of the consent result in a new version of the specific consent that is introduced and appended, keeping also the complete history within the blockchain infrastructure. Another point, of course, in order to be GDPR compliant is the ability for any of the involved parties to withdraw the already established consent. So in this case, a customer can invalidate at any point an existing consent, which is then automatically set to invalid as a new state, and a new version of the specific consent is appended in the complete history of the consent and that are stored and maintained in the blockchain infrastructure. At any point, another thing that's very crucial and also part of the consent management system is to be able to retrieve the complete history of the consents. And the retrieval and display of this latest information, as well as the complete history, as I said, of all existing consent, can be done at any point by any stakeholder that I described with different parameters. For example, any third-party provider can retrieve the complete history of consent that he has received. The customer can retrieve the complete history of the consents that he has provided. And of course, the bank can retrieve the complete history of the consents that the customers provided or any third-party provider received. All of these are translated into the appropriate queries within the blockchain in order to retrieve the information needed. Another thing that we need to I need to demonstrate is that we have considered two major types actually of consent. So one being a permanent type where the consent has an infinite period of validity and can only be withdrawn at any point. But we also have the second case where the consent has a limited validity period that is set by the involved party and the customer. It can expire at any point as set in the terms. So in this case here, we see that we have what we call an once-off consent that expired. Before it's expired, the system informs the customer that there is an upcoming expiration, and possibly the customer can initiate an update and renew this consent, or the customer can decide to leave it as is, and when the timer expires, this consent is considered invalid and expired, and a new version is also introduced in the blockchain. Besides, so now we'd like to show you a video of our solution so you can get a better idea of what we have developed. So let me start the video, and I hope, give me a second.
Hello everyone. Today we would like to demonstrate to you our consent management system. In this blockchain application, we aim at exploiting the blockchain technology and specifically the permission blockchain in order to develop a decentralized and robust consent management mechanism that will enable the sharing of the customer's consent to exchange and utilize their customers' data across different banking institutions. Here, we are looking at three different windows of the consent management system, each one for a different connected user. On the top left window, we can see the financial institution number 1. On the top right window, we can see the financial institution number 2. And finally, on the bottom window, we can see a customer. Financial institution number 1 is considered as internal because it collaborates with our customer. On the other hand, financial institution number 2 is considered external because in order to have access to customers' data, a fully approved consent is required. So, without further ado, let's create a new consent as user financial institution number 2, asking for the consent of customer. First, we need to open consent creation model and add the customer's social security number. While I'm filling the rest necessary details, let me explain to you about the validity period of a consent. With regards to the consents and the validity period, two different approaches are considered. The first approach provides the ability of a once-off consent, in which the validity period of the consent is a predefined period. Once this period is expired, the consent is automatically revoked, and new consent is required for the recipient to be able to access the customer's data. The second approach provides the ability of a permanent consent that has an infinite validity period and is invalid if the consent is withdrawn. When we have filled the creation form, we can either save consent as draft and submit it another time, or we can submit it right away, which is what we are going to do for these demo purposes. As you probably saw, our consent has submitted and financial institution number 1 has been notified in real time via a snack bar message as well as with a navbar notification. Next, financial institution number 1 opens the consent details modal, review given consent details, and either reject or pre-approve it. Now, as a customer user, we open the consent model, review the consent details, and ask agreements. We can possibly edit some of them. After that, we can either reject or press the review button to let financial institution number 2 know that we have agreed with this consent request. Finally, as consent request cycle reaching to its end, financial institution number 2 opens and review the possibly changed by the customer consent details, and if there is an agreement, we proceed with approval and consent activation. After a consent is finalized, either financial institution or customer can update it. So let's say that customer wants to update this consent. So let's open the update modal, review our consent, and maybe we want to change the validity type from permanent to once-off. So that means that we can choose the date that we want our consent to expire. So let's set it to end of March. After this, we press update. As you can see, our consent updated successfully. But now, there is one last step where the financial institution 2 has to approve this update. So as a financial institution 2, we open the model and review the change, which is change to the validity type. If we want to proceed with this update, we press approve. Our consent successfully updated. Now we can check our consent versions by open history of consent model. Here we can have a look on previous versions of the consent. Version number 1 with validity period set to permanent, as well as the updated version of the consent with version 1.1 and validity period once-off, set it to expire at the end of March. At any time, either a financial institution or a customer can withdraw the consent. So, for example, maybe the customer wants to withdraw or cancel a consent. So, we confirm, and after withdrawal take place, this is final, meaning consent can not activate again. Now, if we have a look at history of consents, we can see previous version, version 1, version 1.1, and of course our last and final version, version 2. There are also some other features to our consent management system. One of them is a fully functional search bar, where we can search for a consent, for example, like that. As a customer, we can change between all the consents or just the active ones. We can open the sidebar and see our customers. Well, that was all from our side. I hope you found that video helpful. Thanks for watching.
Okay, I guess, yeah, that was all from our side. Thank you very much. I don't know if there are any questions, or so we will have a QA at the end.
Dimitri, we had a question. There was some problem with the resolution of this video. So,
Okay, yes, I
if it is
understand.
on the Infinitec channel, I don't know if you can see the chat, but I think that this video is on the channel, right?
This will be updated. There is an existing video on the channel that will update this new version. I apologize for the
so
resolution.
we can send the link of the updated video to the participants.
Yes, sure.
I don't know if there are any other questions. Are there any questions to Dimitris? Okay, thank you, Dimitris.
Thank you.
Yeah, this is Mauro. This is not the same video. It's probably an earlier version, but I think you can see most of the functionalities there. So let's move to the next speaker. Let's talk about tokens. Baran, please, the floor is yours. Please take some time to properly introduce yourself. Open your camera. Thank you. Take some time to properly introduce yourself and proceed with your presentation and the demo. Thank you.
Hello, everyone. I'm Baran Kılıç from Boğaziçi University. I was a master's student and recently graduated. I will present our work of implementation of ERC 1155 standard in Hyperledger Fabric. Hyperledger Fabric is a distributed ledger technology. It's open source and targets enterprises. It's modular and has pluggable consensus. Hyperledger Fabric is permissioned, so each participant know each other. Since it's permissioned, there are no transaction fees or so-called gas fees, and since there are no fees, no native token. It do not have any token, but we can implement tokens as contracts in Fabric. Now I want to present ERC 1155 multi-token standard, and we'll show you a video about it.
We present ERC 1155 smart contract implementation for the Hyperledger Fabric. Virtual assets can be represented as tokens on a blockchain and offered to interested parties who can consume or trade them. ERC 1155 is a multi-token smart contract standard that allows representation of both multiple fungible and non-fungible token types in a single contract. ERC 1155 can be thought of as combining functionalities of both ERC 20 fungible token and ERC 721 non-fungible token standards. ERC token standard implements fungible tokens. That is, one type of token with multiple quantities. Each token is indistinguishable from others. ERC 721 token standard implements non-fungible tokens. Here, we have multiple token types, each with a single quantity. Each token is distinguishable. ERC 1155 token standard that is implemented combines the functionalities of both ERC 20 and ERC 721. Here, we have multiple types of tokens, each with multiple quantities. The following functions are available in ERC 1155 standard. Transfer from function transfers the tokens of type id with a given quantity from an account to another account. Batch transfer from transfers multiple tokens with given quantities from an account to another account. Balance of function gets the balance of an account for a specific token. Balance of batch function gets the balances of multiple account token pairs. Set approval for all function enables or disables approval for a third party to manage all of the caller's tokens. Is approved for all function queries the approval status of an operator for a given owner. The following are additional functions available in the implemented smart contract. Mint function creates and deposits token of type id with a given quantity to the specified account. Mint batch function mints and deposits multiple tokens with given quantities to the specified account. Burn function withdraws and burns a token of with given quantity from the specified account. Batch transfer from multi-recipient function transfers multiple tokens with given quantities from an account to multiple accounts. Client account ID function returns the client account ID. URI function returns the URI for a token. Set URI function sets the URI. Here is an illustration of the transfer from function. Here is an illustration of the batch transfer from function. Here is an illustration of the batch transfer from an account to multiple recipients function. We present
ERC1155 is a standard for multiple tokens. It's defined by Ethereum. It supports both fungible tokens and non-fungible tokens. Fungible tokens can represent things like cash, and non-fungible tokens, NFTs, can represent things like artworks, tickets, properties. We implemented ERC1155 for Fabric as a chain code in Golang. It supports all the standard functions of the ERC1155, like transfers, batch transfers, querying balances. We also implemented additional functions to mint tokens, burn tokens, and setting URI for tokens. The code is reviewed by official Hyperledger Fabric samples repo and added to it. You can also reach it using the Infinitec Marketplace. If you go to Infinitec Marketplace and search for ERC1155, then click the ERC1155 and you can find the necessary links under resources section. I want to show some sample function invocations. For example, on the left-hand side, the account A creates 10 tokens of type 1 and a single token of type 2 and 5 tokens of type 3. Then on the right-hand side, the account A transfers the tokens of 2 of his tokens with type 3 to account B. You can execute such functions using this smart contract. We also benchmarked it. We did a simulation and run it on inside a Docker container, and we used 2 CPUs and 2 GB of RAM. We ran 3 different scenarios. In each scenario, 400 users connected to Fabric and executed the transaction. In the first scenario, we made 200 users send a single token in a transaction to another 200 users, and we obtained 73 transfers per second. In our second scenario, 200 users this time sent 5 tokens in a single transaction to another 200 users, and in this way we achieved 255 transfers per second. In our third scenario, each user sent a random amount of tokens to a random amount of users, and we achieved 32 transfers per second. But note that increasing the testbed resources can lead to more transfers per second. For example, Hyperledger Fabric paper demonstrates that it can achieve 3,500 transactions per second in a cluster using a cluster with 80 virtual CPUs. We also connected our Hyperledger fabric to Hedera testnet. Hedera is another public distributed ledger, and it uses hash graph consensus. It targets both enterprises and consumers, and currently has $4.2 billion market capitalization. It pays attention to regulatory compliance. For example, it has account level KYC. It has consensus and token services. It's backed by a lot of companies. At the bottom, I listed some of them. There are large companies like IBM, Google, and there are also big European stakeholders like Deutsche Telekom. There are universities like LSE, UCL, and there are some banks among them. So why connect the contract to Hedera? Hedera can act as a global ordering service. For example, let's say you have different parties, and the party, for example, the blue circle can represent a bank, and they use a fabric chain for their blockchain need. And in this chain, their transactions are ordered. But let's say the gray party uses another blockchain technology. Then they come together and build a consortium and use Hedera consensus service as a global ordering service to globally order all of their transactions. The order of transactions maybe is important for them. For the consensus service integration, we used Hedera consensus service plugin. When we use it, Hedera, the fabric uses the fabric uses Hedera as its order instead of its own order. The transactions are converted into messages and submitted to Hedera consensus service. Then Hedera consensus service reaches a consensus and sends back the message together with its timestamp and sequence number. This integration tutorial is also available in Infinitec Marketplace together with our ERC 1155 code. Here are some screenshots of this service. On the left, you can see my Hedera testnet account ID. Hedera creates this consensus service plugin, creates two topics for Fabric. One is for system channel and the other is for Fabric channel. On the right, you can see the topic numbers, the topic IDs. Under these topics, the transactions are listed. If you click one of them, then you can see inside it the encrypted Fabric transactions stored as Hedera messages. That's all I wanted to explain. Thank you for your attention. I can take if you have any questions.
Thank you, Baran. A lot of dense information. I have a question. Also, I put for everyone the links to the marketplace where they can find the code, also your tutorial. My question is, why did you have to change the order of Fabric?
Oh, it's actually not necessary. So if you use only Fabric, you can use the code as it is, but I want to explain it with this figure. So if you use a blockchain technology, the transactions are, for example, stored in the blockchain and ordered, but maybe they may be multiple different banks and they may use different blockchain technologies. And then if the order of the transactions is important, you have to somehow decide the order of transactions. Since they use different blockchain technologies, it may be difficult to order them. So we only wanted to demonstrate it by connecting the order, by changing the order with header order. If we use, for example, header order, and multiple parties use the same header order, then different blockchains may have, we can order the transactions of different blockchains. We only wanted to demonstrate it.
Okay, so it is for the case where you have different blockchains, right? And maybe not only
Right.
Hyperledger. Yeah. Okay, makes sense.
Yes, yes. But if you don't need anything else, you just can use the fabrics order. It's not a problem.
Okay, thank you very much, Baran. I don't know if there are any other questions. I think this is a good example, and also we give you the code so that you can build a small NFT application. If there aren't any questions, you can check always the chat for the code for the video and for the tutorial, but you will have to register to the marketplace. I would like to thank Baran and give the floor to Nikos Kapsoulis for know your customer on blockchain and how we do it. Nikos, take some time to introduce yourself and your project and go on with your presentation.
I'm Nikos Kapsoulis. I'm a software engineer in Novaks, along with our colleagues during the course of the project in FinTech. We're developing different blockchain applications in order to approach specific problems that can be solved with this new kind of technology, and how it can be exploited by the existing and new use cases on this domain. What we're going to see in this presentation is the Know Your Customer and Know Your Business on-chain data governance provided by the Infintech project. What this is about actually is distributed data sharing in a nutshell, which means that different participants in a common blockchain network, they share their data with privacy mechanisms. So as a continuation of the first workshop, of course, now we're in the second blockchain workshop of Infinitech, and we are introducing again the Know Your Customer, Know Your Business workflow in order to understand better for those that are not they are not aware of it yet. So in this, what happens in this KYC and KYB case is that we have a client, which is an individual or corporation that has to provide their data, who they are, their legal documents, and all this in a financial institution in order to start business relations. In order for this to proceed, actually, the financial institution in the current centralized world, what happens is that it fetches actually this information from shared KYC platforms, and they match the relevant data with the customer, and this is how they validate actually the client, and it is okay for the client to onboard on their system and start having business relations with the legal participant. Because last but not least, what this case is about is how couples actually very good with anti-money laundering and prevent other kind of illegal and terrorist activities, terrorist financing, for example, activities in the finance world. So in the purpose of standardizing this compliance procedure, right now we have the centralized approach, which is very common among the financial institutions and banks and organizations, of course. And this is how they they actually validate a client that they want to onboard on their system. And on our end, on these developments that we're having on this project, we're following, of course, the decentralized approach and how we can share data within a blockchain network in different privacy levels, and along, of course, with starting with validating and onboarding a client. And a note on the blockchain network type for everybody that is interested, of course. We're having this division that there is the public blockchain, of course, which is permissionless and it is open for everybody to join. And what Infinitec adopts actually, it's the blockchain of Hyperledger Fabric, which is a permissioned one, and more details have been already shown during this workshop. And now we will see a little bit what we are doing here and explain in deep and follow up by the video, of course, of the demonstrator. The KYC and KYB on-chain data governance means, as said already, that we share client data on the blockchain, and each financial organization has this privacy mechanism in order. So first of all, we have the Infinitec blockchain network, which is a permissioned one, a trusted network where legal participants, of course, are a part of it. And there is, of course, the corresponding consensus algorithm, and they provided data immutability. On this network is how we run the dedicated smart contracts, the decentralized application, and we provide also the end user experience. The blockchain parties are managing the data on what we call the information groups, and this means that each group of data, which can be 1, 2, or more clients, of course, KYC, KYB information. This is controlled by an organization that the client onboards, and then it's shared to another financial institution, as we will see during the procedure. And we have also the financial company or an individual, could be, of course. And as we started in this workflow, the client wants to onboard and have business relationships with the financial corporations. So in the scenario that we're having, what we're going to see is, from one point, the first financial organization that manages Group 1, which has a specific kind of data already, because some clients have already been identified and entered the system with their KYC and KYB data. It depends always on the case. And on the other hand, we have the second financial institution which has the information group access on the second group. And at this point, the difference in the data sharing is that the one financial institution cannot see, of course, the data of the other one. And again, the information groups, because of this detail, of course, they are privately organized on-chain data. So why we created all this process? Because, of course, we have the undeniable rapid client on board, in the sense that the wants to share their KYC data for one time with the financial institution, and in the second iteration they want to go to another one, for example, and share the data again, which happens in the real world now. This is, for example, something that is committed here. As the client consents that the first institution can share their data. And of course, the procedure and the data updates for the client are very convenient, in the sense that they don't have to reach every institution that they have their data in order to update every time it is needed. So in this context, and having all this in mind, let's see how it works actually and what it is done under the hood. What we are calling here the information group actually is a privacy mechanism inside the underlying blockchain infrastructure, which, as said, it's isolating data from other participants, depending on the configuration, of course. So in that sense, it is an essential concept in the sense that we have a ledger inside a ledger, if someone would like to put it like this. So in this scenario, as the financial institution that has access in group 2 wants to share their data with the first financial institution, of course, all they have to do is to grant a simple to touch a simple UI button and grant their access, and through the underlying blockchain, the data is shared, and now the first financial institution on the left, as we can see, has the access in group 2. In the same manner, the same manner happens by vice versa, and what means that from this point, maybe the financial institution doesn't have the consent of the next clients in order to share their data, so they forbid the access. So in the next clients that they are added from National Bank of Greece, as we have here in the right, in the second financial institution, they are not, they cannot be seen by the first one. And in the same sense, in similar manner, the other financial institution shares their data through a different privacy group on the ledger. In this procedure, they grant access to the other institution, and the other institution can see the data in group 1. Okay, and I will pass to the video.
Regulatory compliance, speed, and security complement the future of data sharing. The Infinitech on-chain Know Your Customer and Know Your Business data governance support financial institutions to share their clients' data in a distributed way. In the presenting scenario of data sharing among financial institutions, the first institution, Bank of Cyprus, manages the Know Your Business data sharing on Group 1, while the second institution, National Bank of Greece, on Group 2. Each bank has forbidden the access to the blockchain information group for the other bank. Particularly when the first institution is inserting new on-chain data in Group 1, then the second institution is unable to see these new data additions. And vice versa for the second institution's data sharing in Group 2. Initially, both banks have submitted different Know Your Business data on the ledger. The first bank has submitted Know Your Business client data in Group 1, while the second bank has submitted different data in Group 2. Naturally, during the system's workflows, it occurs that the first institution requires to register companies that are already clients of the other institution. In order to simplify the onboarding process for both the companies and the institutions, information groups directly make available the corresponding data under secure blockchain privacy. At this point, the second bank easily shares the related Know Your Business on-chain data through the dedicated functionality of the Group 2. Once onboarding is completed, the client data of the second institution is shared through Group 2, and the first institution retrieves the respective on-chain Know Your Business data. In future onboarding and data sharing collaborations of the two institutions, the bank shares directly the new Know Your Business data through the dedicated group. As depicted, new clients are added to the common information group shared by the second institution. Naturally, clients must consent to the on-chain sharing of their data. In case the second institution must cease the Group 2 data sharing, the respective action is completed through the permissions functionality. From this point on, the new clients that are being added in Group 2 are not being shared with the first institution, while at the same time, the previous records continue to be viewed by both banks. In a similar scenario, the second institution requires client on-chain data from the first one, a corresponding procedure unfolds. The first institution permits access to the dedicated group for the second institution. Once the access is granted, the second institution is the related Know Your Business on-chain data shared through the underlying blockchain information group. This is a scenario of distributed data sharing in the Infinitec Know Your Customer and Know Your Business on-chain data governance.
Okay, this was also the video recording of the demonstrator. Thank you for your attention, and we're open to questions here. And our next speaker is analyzing blockchain transaction graphs for fraudulent activities by Alper.
Because before we move to Alper, is this information available in the YouTube and in the marketplace, or are you gonna make it?
Yes, as shown in the video, the information of the code actually and the slides for and the explanation of this application is in the marketplace, in the dedicated link as shown in the video. And yes.
Okay, thank you, Nikos. So let's move on discussing how you analyze blockchain graphs for fraudulent activities. So Alper, the floor is yours. Feel free to open your camera, introduce yourself, and give your presentation.
Thank you, John. Thank you, Nikos. So hopefully you can see my camera, but I don't know right now. Can you see my camera?
Oh, we cannot see you. We can see your slides, but we cannot see you.
Oh.
But yeah, if not possible, we can just hear you and see your slides.
Yeah, I'll in the interest of time, I'll continue and then I'll turn my camera on, hopefully by the presentation. Okay, so I'm going to present to you our work in the Infinitec consortium regarding Pilot 9. So our pilot is one of the few pilots focusing on using blockchain technology. So, and here's an outline of my talk. So I'm gonna show some for those of you who have seen the previous workshop, who have been in the previous workshop. I'm gonna use the same kind of motivation initially, but then demonstrate to you the new work that we have been performing since then. Okay, so basically, we are all aware of the importance of the blockchain market and specifically the crypto assets. And the market capitalization actually hit $2 trillion and briefly came back, I think, after recent events. And there's quite a few interest in the industry for dealing with crypto assets, and including support from likes of Amazon or MasterCard or companies like Tesla. And in fact, MasterCard has recently bought some blockchain analysis kind of companies as well. And as you'd seen in earlier talks, there are many blockchain use cases, from decentralized finance and KYC and content management, etc. So where do we stand in this? Before that, I want to talk about a little bit more about the regulations that are out there. For example, in US, the banks can now provide custody services to crypto assets, meaning people can ask banks to keep their assets as guardians. And the next one is of interest to us for our pilot, because we are interested in finding fraudulent activities that's going on in the blockchain domain. And in that respect, there's a worldwide organization, the Global Money Laundering and Terrorist Financing Watchdog, and they are also aware of the problems that may be arising thanks to this new technology. So they want some effective systems for monitoring and supervising of this new technologies, and specifically crypto assets. And as you know, with the recent war going on, there's also discussion about how do we enforce sanctions on this crypto asset kind of markets as well. And in EU, there is the adoption of the blockchain technology is steadily increasing, and there's actually a body of EU that's focusing on blockchain technologies, and they have presented European Blockchain Services Infrastructure, and which provides a set of services such as data sharing, notarization, diplomas, etc., etc. And what kind of technologies that they use is Ethereum with Hyperledger, Basic Client, and Hyperledger Fabric. Essentially, this allows Basic Client allows Ethereum to talk to the Hyperledger to talk to the Ethereum system or technology. Okay, so after this initial motivation, I'd like to talk about what we do in this InfiniTech consortium and in our pilot 9. Essentially, our goal is to track fraudulent activities that's going on in the blockchain domain. And so far, if you consider the world kind of as the traditional finance ecosystem, we had the traditional banking systems, etc. But now that we have these public blockchains and such, which is demonstrated by this yellow kind of ring around the world, and there is interface of these traditional finance ecosystems with this crypto asset kind of markets through the banks, etc., etc. And so that means, we need to be able to have similar activity detection or in this context as well. Similar in the sense that, people have long had, the traditional markets have long had systems for tracking fraudulent activities. Now we need such techniques for this blockchain environment. So specifically what we did is that first we developed a scalable parallel transaction graph construction. So why do we need this? I'm going to motivate with our next slide, because the number of transactions and the size of, and if you represent this as a graph, is growing immensely. So you need to be able to deal with this large sizes of graphs, and we use high performance computing technologies and parallel programming to reason about this. And second, together with our partner in the pilot, Active Bank, we also have a user interface that provides transaction graph visualization. So this is useful for the end user. Okay, like I mentioned briefly, some of the innovations that we have performed in this project is scalability, thanks to the use of high performance computing and parallelism. And we can analyze complete transaction graphs as opposed to partial analysis that's done by the solutions that are out there that we are aware of. So this is an important addition of our pilot. And we have been using open source libraries. Furthermore, the technologies that we develop for analyzing these large graphs are equally usable in traditional financial transactions as well. So if you want to analyze IBAN transactions using the kind of the technologies that we built, that should be applicable as well. But our focus here is the blockchain graphs. So the transaction graphs, we kind of put some dumps of those things. Here, obviously, you have millions of nodes and millions of transactions. So they are huge. So you cannot have a non-parallel algorithm to and reason about these in a reasonable time. So, so the first kind of technology that we developed after building this transaction graph is that there's a well-defined set of blacklist addresses that are on the internet through some regulatory offices, etc. So we found those blacklists. We can trace communication from those blacklist addresses to an address of interest to us. So for example, here we are showing a hacker's address. So this is public. So we can trace the transactions that this hacker has performed in the graph. Okay, so let's say this this purple address is an address of interest to us. That's someone who wants to open up an account, etc. And you want to know if they have any kind of interaction with this hacker or not. So we can generate a trace of this from the blacklist to the party of interest. So this is something that we had performed, we had completed. Then we extended this work. So you see two diagrams here, A and B. So the first one is what I showed in the previous page. So we are kind of going from generating a single trace, so to speak, from an initial node to a final node. And this is typically what commercial solutions are doing when they are giving you some analysis results. So what we did is we enabled to generate a complete kind of information from a set of nodes to a destination set of nodes. And the use case for this was peel chain activities. So peel chain activities are techniques to launder large amount of cryptocurrency through a lengthy series of minor transactions. So in order to avoid being caught, the hackers are using this kind of technology. So when that happens, the graph or the traces do not look like the one in A, but they look like the one that I'm showing in B, actually. So the analysis that we generate through the technology of Pilot 9 is more complete, and it's a better solution than what the commercial solutions are doing currently. And this is actually a real life complex peel activity, part of a complex peel activity. So this 86X81 is the ID that we're using for the upbit hacker. And you can see that, and we didn't show the amount of transfers here, but you can show that they are distributing their money to in terms of small amounts, and then later on, this bottom row is showing the accounts that they have created, the addresses that they have, and everything is getting back there. So they're trying to avoid being caught through this kind of small transactions. And the next set of works that we are performing is in the realm of using machine learning. So basically, we started, and this is an ongoing work. So we have some initial results where we are trying to use supervised machine learning techniques to kind of to predict, blacklist nodes, blacklist addresses. And for this purpose, we are using, the graph, the information that we collected for Ethereum and Bitcoin. And it's not, but the for supervised learning, we need a set of features, and some of these features are relatively easy to generate when you look at the graph. But then we have features such as PageRank, which is non-trivial, actually. It has complex computation when you're dealing with massive graphs. So we use high-performance computing in this context to generate a feature, which is a global feature, and in this case, PageRank, etc. And what we did is we also made our feature data available to the public on the Zenodo website, actually. So this should be available to the parties who are interested. So we have some good initial results with high accuracy, but we are in the process of completing this work in our pilot. Okay, I guess this is all I have. I can take your questions, and I'm not sure if I can start my camera.
I don't know if there are any other questions, but I have a question. Alper, how do you, for the supervised learning, right? How do you have some ground truth about what transaction is suspicious or fraudulent? What is the ground truth? Because I think this is a new field, right? It's not like a credit card where you have ground truth and past data. Here, what do you use as ground truth? You manually label some stuff, or how does it work?
Yes, thank you, John. So essentially, similar to our earlier work in terms of, given a blacklist address, how do you go from this address to another address of interest? So the tracing that we did earlier, we collect these blacklist addresses from, reputable websites and, places like that, and, public information that's out there. But you're right in the sense that the amount of information that we have in this context is very limited. So that also tilts, obviously, the accuracy, the preciseness, etc., of this machine learning, supervised machine learning type work. And another line of work in this context that can be done is actually anomaly detection. And I believe there is another pilot, although not in the blockchain context, but they are trying to find fraudulent transactions in standard banking transactions. So in short, our ground truth is what we obtain from these reputable sources.
Okay, so it's basically the blacklisted addresses. Okay, exactly. I understand. Yeah, I mean, because it would make sense to try this anomaly detection even with some unsupervised learning, right? And to see, well, you cannot have evidence of fraud, but at least what is different, right? What are the different patterns? That was, yes, please.
So what we did with PageRank, so kind of it gives. So what we have seen is that when you generate the PageRank information for addresses, that becomes a very good feature in terms of determining whether an address could be a hacker or not. So that's PageRank is basically how much communication that address is having. And so that was an interesting finding. And another one is, we have this convex graph generation that I showed in the context of this little transaction for laundering that hackers are doing. So that's also a global information that we can compute over the large, massive graph. And so that is potentially also useful to determine, for example, when we look at the big network and then you analyze, this kind of convex graphs, and maybe you can find or identify potential launderers or potential hackers that have not been identified yet. Okay, so that is not something that we have done, and but this kind of, so what we are trying to do is we are trying to kind of bring technologies to the to the open source, to the industry, where they can analyze this blockchain data and then make sense out of it, in terms of whether there is a problem or not, etc.
Okay, that's clear enough. Thank you very much. So maybe we can go to our last but very important presentation. Actually, it's a multi-presentation by BK and IBM. So maybe Bruno, you start. Please feel free to open the camera, introduce yourself and the project, and give your presentation.
Hear me. Can you see me and hear me?
Yes.
Okay. Perfect.
Yes.
So let me share the presentation and then introduce myself. Okay. Here we are. Okay. Can you see the presentation?
Yes, we can see it. Yeah.
Okay, perfect. Okay. So I'm Bruno Lepri. I'm senior researcher in Fondazione Bruno Kessler, where I lead the mobile and social computing lab that works on AI, computational social science, and also application of AI method to digital finance, to the fintech domain. So here we will present together, FBK and IBM, the framework we were working in the last several months within the InfiniTech project. That is an environment, a framework of federated learning and based on blockchain that has the goal of sharing insights that are the result of local learning models, and to trade this insight between organizations, and in this way to enable a data marketplace, an insight and data marketplace. I will present and will give the initial motivation, then I will leave the floor on the algorithmic part to Gabriele, that works in my group as a researcher, and then Fabiana and Inna will present and introduce the video to describe more the blockchain side of the work. So the motivation and the current situation we have in the financial and insurance sector is that banks and insurance companies have only partial information on their customer. So there is a growing need of sharing information and sharing insights on client and customer, but this should be done in a privacy preserving way. So also in a way that is compliant, for example, to the regulation, to the European regulation like GDPR, but also in a value preserving way. So we can think and having the idea of having organization and banks that have a partial view on the financial behavior of their own customer. They want to trade and exchange this information, but maybe they don't want to trade and exchange the raw data for also business reason. So there are some challenges that are right now existing and are a way to block a little bit the growing of this personal data market, or in general data market, that are the problem of the data that are siloed within organization, and also the privacy that is not really adequate, protected in an adequate way, and also the creator, the people that really build up value with their own data are not involved in the process. So there are new paradigms that are emerging that are also pushed by the regulation, the change of the regulation, and on the other side, they push the changing of the regulation. New paradigm in computing and sharing data and information. So one of the ideas that raw data never leave a data repository, are processed in a local way, so there is no storage, centralized storage of data. Another idea is that so there is a move of the algorithm to the data and not the opposite. So an organization that want to access information of another organization does not require data or raw data, but move his own algorithm to the other organization. The other organization process locally the algorithm and give back answer, safe answer to the organization that needs the information. And also the idea is that, so this start a trading of insight and not raw data. Other things are the vetting of the algorithm. So the algorithm are checked for data provenance, for privacy violation, for biases. And there is a growing movement toward decentralized architecture, so blockchain-based, and that use also smart contract. What we built, it's a framework that that has the goal to permit the access, the management, and the sharing and trading of insights that are the result of local adoption of machine learning algorithm on data in a secure way, and permit this across financial and insurance institutions based on a federated and cooperative learning algorithm that Gabriele will give more details, based on random forest, a secure execution framework that is built on top of Hyperledger Fabric blockchain, and that provide an environment for computation that is privacy preserving and is accountable and verifiable. And we have adopted in this case 4 scenarios of federated learning, federated machine learning. And then a data marketplace based again on Hyperledger Fabric blockchain that support the managing, but in particular the trading of the learning algorithm outcome, result, and insight using digital token. I will leave the floor to Gabriele. I can move the slide. You can only to say next.
Okay.
Okay, go.
So thank you, Bruno. So I'm going to give some detail on the algorithm that we are implementing in this framework. So I would like to mention first that we are working on a paper that is cited in the footnote, and we will be happy to share a preprint as soon as we have one, if someone is interested. So our algorithm is based on a random forest classifier, so a rather classical method, but this allows to implement several details of this sharing mechanism. So the idea is that every single node is able to fit a random forest and to identify a ranking within the different trees within this model. And we also implement a crop mechanism, so a way to reduce the number of trees that are maintained locally. So let's say that every node in the federation is able to have a local model to classify anomalous event. And then we have two ways to share this knowledge. So there is a sharing step, so a way to share with the neighbors some part of the estimator that have been locally fit. And on the other hand, every node is able to collect the shared estimators from the neighbor node and include them in the local random forest. So this is the basic building block of the algorithm. And Bruno, if you can change.
Yeah.
Okay, and this simple design has some nice advantages that also with respect to the integration with the blockchain technology. So the first one is that design is rather simple. So it's really easy to have this modular design where the models can be incrementally improved. And also we can implement explicitly memory bound. So every node is bounded to have only a maximal amount of information that needs to be stored and traded. And also the algorithm is fully asynchronous. So there is no need for the node to wait for a local and centralized synchronization. Also, we support a time varying network. So there is no need to know in advance what is the federation, but we can just accept that different nodes join the federation at different time. And also the mechanism is robust to the node's misbehavior because every single node is responsible for accepting or not or rejecting the information that it receives from the neighboring node. And next, please. So I'm just going to briefly show a quick result on a benchmark dataset on fraud detection that can be found, it's open source online, and is a simple fraud detection dataset with 28 numerical features, and is about credit card transaction in September of 2013, and is a rather large dataset with just a few frauds. Okay, so it's rather difficult to identify fraudulent transaction, and it means that it's convenient to share information with the neighbors that can have complementary information. We simulate a setting with 10 nodes, so 10 agents, and every one of them have only a part of the dataset. And we test 3 different connectivity scenarios. So one where everyone works by its own, so there is no federation at all. Then a second one that you can see in the center, where every node is able to communicate only with the neighboring one, and then a fully connected one, where the full communication is exploited. Next, please. And first, I would like to show you the result of the sharing of the insight at the end of the simulation. So you can see in the example of the pairwise connected nodes, you can see that on the right there is a number of estimator that move from one node to the neighbors. Okay, and the next. And in the next one is the fully connected network, and you can see that there is a much larger sharing of the estimator. So the knowledge is able to move across the network. And the final slide, please. So just briefly, this is the result of the aggregate improvement if the node are able to work in the connected setting. So blue bars are the pairwise connected, and the fully connected, and the orange one are the pairwise connected. And what you see here is the mean and median improvement in different accuracy measures, so balanced accuracy, precision, and recall, when you compare the federated approach with the fully disconnected. So you can see that depending on the setting, we get up to 12% improvement in different kind of accuracies. And for the full details, I would like to refer you to the paper that will be ready soon. And that's it, and thank you for your attention.
Thank you, Gabriele. So I will close the sharing of, I think, my screen, and I will give the floor to Fabiana to introduce the video. And so, yes.
Yeah, hi. So thank you, Bruno and Gabriele, and hello, everybody. So my name is Fabiana Fournier, and along with Ina Skarbowski, we work at the IBM Research Lab in Haifa, and we were in charge of the blockchain side of what you just saw. So FBK explained the motivation for our work and showed you the federated machine learning side of the proposed framework for a blockchain-based federated learning environment and data marketplace. We will now watch a short video, it's about 8 minutes, that will give an overview of the blockchain aspects of the realization of the framework in the fraud detection use case shown by Gabriele. As you just saw, blockchain actually plays a dual role. It provides a secure, trustworthy, privacy-preserving, immutable environment for the execution of the federated machine learning algorithm, and it also enables the trading of the outcomes of the learning process using digital tokens. This movie, as well as the full demo of the solution, which is quite long, more than 30 minutes, and gives a deep dive into the technical aspects of the solution, can be accessed through the project marketplace. And with this, let me just show you the video.
Hello. This video presents a demo for the blockchain-based federated learning environment and data marketplace by Fondazione Bruno Kessler and IBM. We're going to assume that you're familiar with blockchain technology and its basic concepts. What is federated learning? Federated learning is an emerging approach to establish cooperation between a group of agents that are solving a machine learning task. The goal is to improve each agent's performance without disclosing any data. This means that one organization has to trust another organization to locally execute the machine learning algorithm on its premises using its own data. Since the computation is defined by one party, the algorithm's owner, and the data is owned by another party that also runs the computation, there may be an inherent trust problem. How can we ensure the correct computation is performed and that the reported results are the corresponding outcome of that computation? What do we want to achieve? We propose a framework that allows the computation to be delegated to the data owner while ensuring the provenance of the computation process. This framework supports the sharing and trading of the computation results in a controllable and secure manner. What's the scope of the work? This work is a joint collaboration between FBK and IBM as part of the Infinitec project. FBK developed a fraud detection federated learning algorithm that's run by a consortium of organizations on their own nodes and on their own data. But these organizations all share the intermediate learning results with each other to achieve higher precision. IBM provides a blockchain-based secure execution framework for the distributed fraud algorithm execution, recording all the meta information about the algorithm's execution and recording the shared intermediate results on a transparent, immutable, and verifiable ledger. At the end of the execution, a completed model can be shared as a tradable asset on a blockchain-based data marketplace, which is also developed by IBM. The blockchain-based data marketplace provides a tradable assets catalog where consumer organizations can search for and access available assets by paying for those assets using digital tokens. In this demo, you'll see the entire flow. It starts with development of the federated learning algorithm and publication of the algorithm image. Next, the image is run by multiple organizations who share the intermediate results on the chain. After that, we show creation of the completed model and how it's published on the marketplace. Finally, you'll see how this model is then purchased by an external organization. But first, here's some background on the demonstration environment. For the demo, we have a Dockerized deployment of the Fabric blockchain on a Linux machine, along with an API service client application implemented in Node.js. This client application wraps the Fabric JavaScript SDK and provides RESTful API services for interaction with the chain codes that are deployed on the blockchain network. We have a local Docker image registry for storing the algorithm image, but of course any other image registry can be used to publish images. During the demonstration, Docker containers from the federated learning algorithm image are instantiated and run locally, but they can also be run in a totally distributed manner as Kubernetes pods, for example. Here are the steps of the demo scenario. 1. First, the algorithm developer builds a Docker image for the federated learning algorithm. 2. The developer publishes the image to a Docker image repository. 3. Then he registers the image metadata on a chain by interacting with the blockchain platform through the API services client. In the next stage, the consortium of organizations that runs this federated learning algorithm starts the distributed learning process. 4. The admin runs the script to initialize the learning process, and the image metadata record is read from the ledger. 5. The Docker image that is based on the image metadata is pulled from the image repository. 6. The distributed learning process is initialized by pulling the appropriate configuration information of the participating organizations and their respective computation nodes and creating the learning process record on the chain. 7. Next, the learning process orchestrator script needs to run the first iteration of the computation on all the nodes. It creates an execution record for each computation on the chain. It also creates private and public keys for each computation task and stores the public key in the execution record on the chain. In the following step, the private key will be passed to the Docker execution container, where it will be used at the end of the computation to sign the results. 8. In this next step, the orchestrator script creates a Docker container from the federated learning image for each node running the computation. It passes the private key as initialization to this container, and this container is executed on the organizational node using the organization's data as input. At the end of this execution step, the results of the computation, signed with the container's private key, will be used to update the execution record created for this container. The chain code that writes the result on the ledger checks that the signed result matches the public key stored in the execution record. In this way, it makes sure that the result is indeed reported by the correct execution entity. Steps 7, 8, and 9 are repeated in a loop until each node finishes its calculation. At each iteration, an execution record is created per node, and containerized execution of the image is started on the node to pull organizational data. The previous results by other nodes are pulled from the blockchain execution records for previous iterations. The computation is executed, and the completed signed result is published on the chain. At the end of the computation of all the nodes, the learning process status is updated to completed. The final outcome of the computation is a completed model that can be traded with external organizations. This model is stored on the blockchain data marketplace. The tradable asset record on the chain contains metadata related to the asset creation process. For the federated learning model, this information would be, for example, an algorithm image that was used to create the model, the learning process that produced the model, the owner organizations, and the price. This information is searchable and can be used by organizations to search for and find interesting assets for consumption. The record of the asset also contains the model binary itself, which can be traded with external organizations. The red arrow represents the actions of an external organization that is working with the data marketplace. It can search for appropriate assets by querying the blockchain data marketplace. It can then request access to the selected assets. If the organization has enough funds in its token account, the access request will be created and approved. Otherwise, it will not happen. When an organization tries to access the asset, the chain code checks that the access request for this organization was approved and that this asset exists. The access is either granted or denied accordingly. To sum up, we presented a blockchain-based secure execution environment and data marketplace for fraud detection federated learning. The possible extensions to our work include the following. We can use the same framework to support the execution of various algorithms, as long as they can be represented and packaged as a computational task in a Docker image. In the demo, we demonstrated cross-chain code invocation of previously developed ERC20-based token smart contracts inside the data marketplace. Instead of ERC20, any other ERC-based token smart contract can be used in the same manner. In our demo, we also showed simple functionalities of a marketplace to illustrate the digital trading of learning models while applying tokenization on the blockchain. This data marketplace could be extended to provide more functionalities, from richer query capabilities to pluggable pricing models and advanced trading options such as auctions and price negotiations. Thank you for listening.
So I guess that was the end of the video. So if there are any questions for any of us.
Fabiana, the technical, I don't know if this question is for you or for Bruno, right, or Gabriel, but I think that the technical presentation was very deep. I am missing a little bit more, information about the application of this, right? I mean, is it in finance and outside finance? Is it, for example, for trading my personal data in healthcare, or for financial institutions to share data for some risk assessment? What is, the practical application of this today?
Yeah, so thanks a lot, John. So the framework is both possible to be adopted by a scenario where you have, I don't know, citizen or group of citizens For example, the idea of the data cooperative that now is emerging, or the original idea that was out some almost a decade ago of the personal data store, so where citizen can control the sharing of data. So the main message here is that instead of moving data or raw data, also if you are a citizen, or in case you are in an organization, you should build up a framework that permits that the processing of the data, it's always in the local side. So if we have personal data store, the processing of the data is done within the personal data store. So an organization send algorithm or some description of the algorithm and get back, as was in one of the original idea of the personal data store, safe answer, but never there is a trading of the raw data of the citizen. And the same thing is for the organization. So if we have, I don't know, two banks that want to share information, they share information and they share insight without sharing the raw data. So it's not that the bank B send the data to the bank C, and then there is a place controlled by bank C where the data are merged and where there is some processing. But the bank C asks information to the bank B process the things at the local level, and then share parameter or share insight, outcome. And then this sharing is done on a blockchain framework, so it's transparent, and also can adopt the token instrument as a way to trading and associate a monetary value to this step. But one of the ideas is really try to avoid as much as possible the sharing of raw data and raw information, and this is the reason because we try to connect the federated learning type of approach to the blockchain and trading with token, to have a personal data market or a data market in general that avoid in any case the movement of raw data, but process data.
I mean,
or
the movement of raw data I can avoid with just the federated learning part, right? I don't need the blockchain part for this. I mean, for the first part that you described, right? So to keep the processing local, right? I can do this with federated learning, federated machine learning. I don't need the blockchain to accomplish this.
The blockchain ensures that you have a secure environment for the execution of the algorithm. So you can prove which image was used and which iteration of the algorithm was executed, and so on and so forth. That blockchain, as I said, blockchain has a dual role here. On the one hand, it gives a secure environment for the execution of the algorithm. And on the other hand, it gives you the data marketplace using tokens. So these are the two roles that the blockchain plays in here.
Okay, so it's the enabler for the market mechanism, right? Based on the tokens. If I take the decision to share my data, right, I can be rewarded.
Yeah, this is the second part. Once the algorithm finishes, so it's completed. So what do you do with the models? So you put them on the marketplace and you give them a price, and then an external organization can actually purchase it. Okay, so tokens, it's a means to do so. And during the learning algorithm, it provides the secure environment for the execution of the algorithm. So you can trust without having a third party which algorithm was executed by whom, when, iteration, and so on and so forth.
Okay, so first is transparency on the algorithm and auditability on the algorithm, and then it's a sort of data market. Maybe, you know, in the future, a very important piece of data would be an NFT, right? A very important or unique piece of data could be an NFT, and you would be able to trade this on a blockchain.
Yes, as we said also at the end of the movie, the framework is very generic. So we just realized one MVP using the fraud detection algorithm, but you know, it can be used in many other scenarios and also with other standards for tokenization. And ERC 1155, for example, it would be very straightforward. We just did a small MVP so far, but it's using NFTs, it's straightforward.
Okay, very good. Thank you. That's all from my side. I don't know if there are any other questions for the audience. I think this last part was really very, very interesting and very novel, this combination of federated learning and blockchain. Otherwise, this leads to the end of this workshop. I would like to thank everybody who participated, but especially all the speakers. And I want to remind everybody that this meeting has been recorded. So we will make it available. We will make it available in the YouTube channel of the project, and we are gonna send the link to the participants. Also, maybe the presentations will be also made available. So thank you very much, and enjoy the rest of your day. I'm just stopping the recording. Thank you very much again.
Thank you.